Hi, I'm Stu Rich with today's interview in the Facilities Management Minutes series. Through these interviews, we want to share insights with you from some of our most interesting thought leaders. Our guest today is my friend Dale Lutz. Dale and his partner Don Murray founded Safe Software in 1993 to break down the barriers of data format and structure that were preventing good decisions from being made in a timely way by users of spatial data. In the years since, Dale and Don have built one of the greatest examples of what a software company can and should be, in my view. Safe Software has built a nearly cult following around the world, and Dale has gained amazing experience and perspective by supporting so many different kinds of customers from all over the world. If you like these interviews, please tap the like and subscribe buttons to make sure you are notified of new content as it is released. And if there is someone you want to hear about in this series, let us know in the comments below or by reaching out to marketing@cartograph.com. Dale, it's great to see you. Thank you very much for making the time to be part of this interview series. It's already been a great set of conversations, and I'm really looking forward to the perspective that you have to share with our guests today. So I appreciate your time.
Well, thank you so much for having me. It's an honor, and I think it should be a lot of fun.
I think it should be a lot of fun too. So let's start out with just some background on Safe Software. You and Don have been in this business for quite some time, but what was the challenge, what was the business problem that really started you on this path in the first place, and how has that evolved or changed over the years?
Well, it's so interesting. As I was prepping for some of the questions that are coming up, it's really the case that the problems of 28 years ago, some of them haven't really changed in all that time. And so if you go back to our humble beginnings, it was just the two of us in our spare rooms with cheap PC computers, which in 1993 you could actually do some serious development on. You couldn't have done it in 1990, but by 93 you could. And we had the chance to work on solving the problem of data exchange between forest companies and our BC government. The forest companies using largely CAD software to do mapping, the BC government using primitive early GIS, and the BC government not wanting to be in a position of dictating tool choice. So a neutral intermediary format to end all formats, which we will talk about later in our time together today, was invented called SAFE, S-A-I-F, and we won the contract to build software to go to and from SAFE from some of these different things with an eye on solving these forest data exchange problems. And we very quickly, we thought actually at the beginning that this format to end all formats was going to take over the world. And there were early efforts to make it part of the SQL MM multimedia parts of SQL. And also actually the earliest OGC meetings were held here in BC. And this SAIF was kind of given to these organizations. In the end, SAIF basically petered out in Saskatchewan. Like, it did make it all the way to Saskatchewan from British Columbia, but the ideas became the root of arguably what became GML and arguably what became the spatial operations that are today in almost all the databases. Actually, PostGIS was funded by the very people who funded SAIF here in British Columbia. So that the impact of that ended up being long-lived. But we learned really quickly that the fundamental issue is people's data isn't quite where it needs to be shared. And what are your ways of solving that? You either do things manually, click, 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 not very scalable, very, very mind-numbingly boring, or you write custom code. So you hire an army back then of Fortran programmers, today Python programmers, to do this. Also kind of brittle. If things change, you got to find those people, they got to do it. Or lastly, you give people a set of very high-level primitives so that they can quickly perform the operations that are needed to do data model integration or exchange restructuring, and you outsource the problem to all those users. And that was the route we went to. Right at the beginning, I remember us saying, you got to pay the piper somewhere, and let's let's make that as easy as possible and not do that ourselves. Let the people in the field do that. And that will foster data exchange, whether it's between CAD systems and SAIF or between anything at all. And so that was kind of the origin story. What happened was we built a few translators that went in and out of SAIF that used this way of thinking. But like all good innovations, basically it was spurred by laziness. I was the guy back then that had to build these things. And we were up to, I think, 6 or 8 pairwise translators. So you go map info to safe to map info. And every 2 weeks I'd have to go to the effort of building these, uploading them to an FTP site. And it was a pain. There was 8 of them. And I thought, you know what? Don had made a brilliant infrastructure here. All of these are cut from the same cloth. Can I figure out a way to put them all into one program? And so together we worked on a weekend. And by Monday morning, we had one program that was the universal translator. And you'd tell it when it started up, hey, read from CAD, go to SAFE. But then we realized, you don't actually have to go to SAFE. You can read from CAD and go right to GIS. And this SAIF format, end all formats, got pushed from being the center out to the leaf. And as a result, we ended up with this tool that could then be configured to do data exchange between most anything. And the rest, as they say, is history.
Well, that's pretty fascinating. And I suppose in there somewhere is the name of Safe Software in another story.
Yes, it was a joke. We thought, hey, we think SAIF is going to rule the world, but we're not that sure. But let's name the company to rhyme. So that was how it was. And actually, we managed to get safe.com for $50. We could have had anything. We didn't buy SAIF.com, and I've actually never checked if it's available, but I don't think it's a hot product.
Well, buying safe.com at the time was a stroke of genius. That you couldn't buy it for that today, for sure. So as you point out, it turns out there are lots and lots of different formats. And in the past, however many years, there have been many different standards to govern how those formats can and should be applied. And different software companies have, of course, their own formats and their own approaches, which I think is good in the grand view, but it also makes it necessary to be able to interoperate between one approach and another as projects move down the line or as different groups get involved. Help us understand how data interoperability can really drive value in this kind of an equation.
In the boiling it all down, really, it's all about getting information from where it is to where it needs to be and making sure that when it arrives, it's absolutely the most useful it can possibly be. And, you hinted at already in our discussion, we talked about proprietary formats that different companies have that I would call operational formats. They have been designed to be worked on and used in an operational sense. Then there are standard formats that are more for data exchange. They are not usually operational formats. And so right away, we have two camps that are designed with different purposes, but there is a need to bring the data across between them, and it almost never lines up. And so you have to provide people, in my opinion, an easy tool so they can make those rearrangements very, very simply so that when they get it to where it's going to need to be used, it's able to be reused right away, and it's fit for purpose. Something is known about the quality, something is known about the data model. It's able to be used without much fuss or muss. And you need to be able to do that all for it to add value in a not time-consuming way. We often say, what's our competition? It really is people writing Python code. And if we aren't able to get that solution done more quickly than writing Python code, or heaven forbid, re-entering it from scratch, then we just haven't done our job. And if you think about over the years, we started off with CAD to GIS. The CAD people had a data model that involved colors and line thicknesses. And somewhere there was a spec that said if it's a green width 2 line, then that means it's a logging road. The GIS person doesn't want to see green width of 2. They want to see logging road. And so somewhere you need to express that transformation, those rules very, very simply, so that when that CAD file gets to GIS, it's ready to go. And by the way, back then and even today, there's a need to go back the other way, so that when you go from the logging road to the CAD technician, they get it with the specs that they expect. And that was our starting point. But since then, so many different scenarios have happened. And I know closer to your work, Stu, is the whole BIM and GIS back and forth. And there's this rich BIM model, but the GIS person might just want a floor plan. So how do you make something fairly simple so that you can squeeze that floor plan out of that BIM model without a lot of effort? And that also relates to the whole emerging field of indoor mapping, where again, you're taking these models that weren't necessarily intended for indoor mapping, but they have the pieces you need, and you pick them out and get what you want. And that can add huge, huge value and feed a whole other market actually downstream. So it's all very, very exciting. I want to tell one more story about, this was a decommissioning of a nuclear power plant. So the power plant was pre-CAD built, but the administrators there, the caretakers, had used Microsoft Excel as a raster GIS, basically. So the cells corresponded to squares in the facility and had annotations in them, so like letters that told you what was going on in that spot. And so that was an example where, hey, it was a system that worked for them. But of course, if you're trying to do some sort of analysis in modern situation, you need to wring the value out of that. So we managed to work, our partner Suico managed to take those Excel inputs, the strangest Excel files you've ever seen, and actually treat them as if they're rasters and vectorize it and get into GIS. And then you could start to make some interesting calculations. It's all around getting the value, showing the value, and doing it fast and more accurately and better than redrawing it.
That's really interesting. In our facilities world, we see this pattern very often of needing to aggregate information from several different systems into a new set of information that reveals more about the nature of that particular facility. You might be pulling employee information from your employee system and scheduling information and maybe energy consumption information all together, and the sum of the parts is much or the whole is much greater than the sum of the parts. Do you see that pattern in other business domains too? And how have you found safe software, FME, to really contribute to that value aggregation process?
We see that pattern over and over again. It's extremely common that people are augmenting the data on its way through the transformation process with our system. And so there's a few ways that we think we can add some value, or that people do that and get great results. One of them is you can easily build QA, quality assurance, in along the journey. When you're aggregating data from a bunch of places, you want your end result to be as trustworthy as it can possibly be. And I hate to tell you this news, and you're going to be shocked to hear this, Stu, but the world actually is filled with bad data. And it's a dirty little secret, but it's true. And so having ways that you can do some tests and ensure that what you're outputting isn't garbage out is a key piece. And, we did a webinar actually just recently on about metadata, which normally is what I consider to be a fairly boring topic, but we found a way to make it fun. And we asked the people, what was your top concern? Overwhelmingly, in the 200 attendees that were there, was data quality. And I think that that's a key foundational piece in all data transformation, is ensuring data quality. The second thing that I wanted to point out is that as you're bringing data together like this, you need to be rationalizing the data model. Almost certainly, when you bring these pieces together, there's going to be different language, different domains, different measures used, and you need to bring that all together and do some tweaks in the aggregated result to present a unified output. Otherwise, it looks like something that was kind of glued together from 4 or 5 pieces, and that may not be as easily used by the end user. So taking advantage of the transformation options to rationalize the data model along the way is very, very important. And the last thing I wanted to say that is often also forgotten is that the process needs to be documented. So how that data was brought together, it is useful to have an artifact around that tells you quickly what that was. And we've seen customers, in our case, there's a kind of flowchart diagram that is created when customers configure a transformation, and they can annotate that. And we're always looking at ways to make this more expressive. But we see people plotting these out and hanging them on the wall so they can share, they can socialize that knowledge about how this key output is being created from the pieces in their company. So those would be some of the things that I would say in answer to that.
Your observations on data quality, I think, are quite interesting. There was an interesting study out from the Harvard Business School a few years ago, and they found that pick your business problem or your workflow. That workflow will take you 10 times longer if any of the data that workflow is dependent on is flawed in any way.
Wow.
So the impact of data quality on the cost of business process is way bigger than we might imagine. And to your point, there's a lot of crap data out there in the world.
I have to admit that I was never as enthusiastic about this piece of functionality we built called the geometry validator in FME. I guess it just didn't sort of, it wasn't flashy, but it's an extremely important thing, and customers do use that to make sure that the geometric construction, if this thing says that it's a polygon, it's not doing a figure 8, it's not bad in some fashion, it's not degenerate, and that's a big deal. We also built in over the years an attribute validator for the same reason, so you can encode in bulk a bunch of rules to make sure that things are the way that they're supposed to be. And I've attended whole talks, like a half-hour talk about just all the ways that dates can go wrong. There's a lot of bad dates in every interpretation, I think, of that phrase. There's a lot of bad dates out there, Stu, and at least we can try to build software for our interpretation of bad dates to make them less common.
So Dale, you come from a geospatial background. There's kind of a pretty strong geospatial thread that runs through your whole career. We tend to talk about location as an organizing principle. It's that spindle that allows you to bring data from different systems together and make sense of it. How has geospatial data served that purpose for your customers, and where do you see that really driving new opportunity?
Well, as the real estate people will tell you, the 3 most important things are location, location, and location. And it is interesting because I would make the claim that in many ways, location is a universal key field. It is an implied thing quite often. It's just there, but it can be exploited. And so joining on location is, of course, the bread and butter of GIS and spatial reasoning. We have a variety in our product of spatial join operations, whether they're containment, the very popular point on area. Lots of problems in the world boil down to I've got these areas and I've got these points, and I need to figure out what points are in what areas. And so that's a very common kind of spatial join. But then you get into more of the more advanced things like proximity, saying, hey, a door needs to be connected along one edge to the wall. And if that isn't the case, then we got trouble. So there's these kinds of interesting spatial predicates that the OGC has built a very solid theoretical foundation underneath that can be used to ensure quality and make decisions in data integration workflows that can produce very, very high value results. So, questions like, is the phone near a tower? Is this building in an area that's zoned for population growth? Is the room, are all the rooms on this floor within some distance to the exit? All these kinds of operations at their core are spatial reasoning ones. And honestly, it's been very, very gratifying and exciting over the years to be able to provide a tool that can answer these kinds of questions. Shortest path stuff, we have got that in FME as well. And we can tap into online services for routing. ArcGIS Online here, precisely, all these folks have online services that can help with routing as well, and we can tie into them. So it's very, very exciting. There's lots of data integration tools out there. We started from a spatial vantage point, which I think gives us an advantage for a pretty big set of problems when it comes to data integration, because location is, the folklore is it's 80% of all data has a location element. I'm not sure I'd go to the mat over that, but a lot of data has a location element, and being able to reason about it and apply these kinds of things, no matter if you're working at the inside or the outside, the up or the down, as your slogan says, I think it all is important.
I think we've established that pulling data together from other sources and creating a new kind of information product is really valuable. I also know there are a lot of customers out there who are terrified by the words systems integration. And the implication is that they're going to have a team of Python programmers that are trying to wire this endpoint to that endpoint, and once things change, they're in a world of hurt. One of the real exciting prospects I see for SAFE and FME Cloud is this ability to enable a more systematic approach to this endpoint integration and really reduce the risk of systems integration. Do you see that too? And do you see that as a big growth area for SAFE?
Absolutely, it is. I just saw a report in the last couple of days in our sales channel in Slack of a demo we did for a municipality somewhere, where we showed how easy it was to take Survey 123, ArcGIS Portal, and pump things into CityWorks to create work orders in there. And the customer was blown away by the ease and speed of that. And this type of integration, which is actually very exciting in this era we're in now, of so many things being services of some kind and APIs, that is where we can add another set of enormous value. So one kind of value we add is rearranging and integrating data and rearranging data models. Another one is the systems integration piece. So our goal is that we want to make systems integration fun. So we take the drudgery out of it and make it really straightforward and simple to piece these things together. And the tools, the environment that we can work in, the tools that are available as inputs to us are just amazing. And so we can give people a way to solve this without caring about code. So they don't have to write any Python. That's the key thing. They can concentrate on the data. They can concentrate on where it starts and where it needs to go. Typically, these ones need very little transformation along the way. It's really just connecting the dot to dot, basically, to put the answer together. And the customers or the administrators aren't burdened with all kinds of minutia and detail. They can work at a pretty high level, and they can design in robustness from the very beginning by using a flexible transport mechanism like JSON, where you can just throw things into sort of a bucket and then pull things out as needed. And actually, we were just talking, Don was just letting me in on kind of a brainstorming idea that we have on FME Server for even building in the concept of enterprise service bus or a messaging framework really in as a native thing to our platform to even make this even easier in the future. But absolutely wide application of it. If I look at our sales figures, I'm seeing that our FME Server product now is closing into being basically as popular as the desktop, which it used to not be anywhere near. And I think a big key reason is a large chunk of people doing exactly this problem.
I think a countervailing perspective to this, perhaps to the perspective of trying to pull appropriate data from wherever it might exist into a new form, is this concept of a universal data environment. You hear this kicked around from time to time, and proponents of a universal data environment, I think, envision a data store that houses really all the data that anyone would need for a particular, for any business problem, really, and then you pull data down from that that's appropriate to your particular need, and I suppose then contribute back if you alter things. That seems like an even more ambitious problem than making systems integration fun to me. What's your perspective of the universal data environment, and how is fun systems integration maybe a better approach?
Well, I'm a big Battlestar Galactica fan, and as they said in there, Stu, everything has happened before and everything will happen again. The quest for this golden ring, the one format to rule them all, I already told you our origin story was SAIF was to be that. And then along came GML, and it was to be that. And then these different kinds of dialects, IFC in kind of the building world is to be that. But always these things, they either end up being not quite rich enough to solve every problem, or so rich that they're too complex and no one wants to deal with the complexity. In modern times, in 2017, I think was when I remember hearing about it the first time and attending some presentations. And you can find this online. Autodesk had this idea of the CDE, or Common Data Environment, that was very promising. But here we are all these years later, and it's certainly not, in terms of the vision that was articulated then, I don't think that's reflected in products today yet. But it's a great, great goal. And the idea of that model was that you have one object to represent something in the real world, and then each application can kind of add onto it the properties that application cares about. But all these things kind of hold promise, but never really get there. And I think the reason is that at the end of the day, to quote the children's story, there is a piper that needs to be paid. You have to find a way to reconcile the differences in your own data model, wherever your data is starting, with whatever this format to rule them all is going to want. And then on the other side, the other way around, whoever's going to consume this is going to get the format to rule them all. And then they have to reconcile that model to what they actually want to have. And so you have to pay this piper. There isn't a free lunch. And so what our experience has been is that for at least a large set of scenarios, it's better just to give people simple tools with great power and allow them to do this work, allow those tools to do this work, and allow those customers to do that configuration quickly and easily for the specific needs of where they are sitting. So very, very often for any kind of interesting amount of data exchange, it's seems to have been better to go point to point and just go from where it is to where it needs to be and avoid that stop in the middle, unless there's some compelling reason why you want to make that stop in the middle.
One of the themes that has been through this interview series is the theme of standards. We've interviewed a number of different folks that have been involved in standards initiatives. We've interviewed Deke Smith, who was very involved with the initial National CAD standard, and now more recently the Building Smart community. Thomas Colby with City GML, the ISO 55000 asset management standard. And it's been my experience that these standards organizations serve an absolutely critical function in our technology world. That said, they also tend to be rather slower to new innovations than the software community naturally. And there seems to be this tension between sort of the more innovative software vendors trying to get out ahead and do new and interesting and more complex things, and the standards community, which takes a little while longer to catch up. Is there a role that safe software can and does play in bridging that tension and helping make sure that you can pull your new shiny data back into a common standard and interchange that with other platforms, and is that something that your customers are making good use of today?
Yes. Right from, our very origin story really was around a standard of its time, SAIF. And in modern times, we have really been, if not first, but very fast to try to support GML or the latest GML dialects, City GML, these kinds of things. I think that those standards over the years have really driven forward the industry, even if sometimes the standard itself may have some issues or may not be appropriate for some use cases. Nonetheless, the work that went in brings everybody forward and it results in a better environment for us all to work in. But the joke that we've heard thousands of times is the thing that I love so much about standards is that there's so many to choose from. And that has always been the world that we've lived in, and we have tried not to play favorites and tried to support whatever we can. I remember early on around this tension between vendors and the standards bodies when KML first appeared on the scene. I think it was 2005-ish, and we had a 2-week head start. I had gone to Ottawa for a conference, and turned out that the mapping group of Nunavut, one of our territories here in Canada, was a customer. And I thought, their office was in Ottawa. I'll go visit them. And I go and I see the door, and I just grabbed the handle and walked in. Well, I didn't realize, basically, I just barged into some guy's office. It was just one guy there. And whoa, he was kind of surprised to see me. But I was blown away by that visit because that guy was using Google Earth before Google made it public. It was a keyhole thing, and he showed me KML, and I came back to the office, and we had a 2-week head start to try to support this KML thing. And the GML people, they're in Vancouver, were kind of mad at us that we were going to be supporting KML because they viewed KML and GML as competitors. Well, KML served a little different purpose than GML. It was an operational format used by Google Earth. In the end, years later, KML became an OGC standard alongside GML. And so the formats can evolve, and there is room for both kinds of things. Another standard I really think has been fascinating to watch is the GeoJSON. Basically, a self-appointed group of a handful of people decided to come up with a standard way of encoding spatial data in JSON, and they just declared it, and so it was, and it's a thing, and nobody particularly appointed them, but there was agreement. It's simple, and it took on its own life, and now it is a widely used thing. And of course, we tried very hard to be supporting it right away. So, in another area would be like GeoPackage. That's another standard. It has lots of interesting things. We have along the way either funded open source and used it ourselves afterwards, or done some work on it ourselves. But we really have been trying to keep on top of that as well. So all around, I would say that it's in our DNA at the company to support these standards. Ironically, they increase our market, not decrease it. Some people over the years thought if everybody would just use a standard format, there's no need for safe software. Well, the answer is FME is still needed to go in and out of that standard. So, hey, we're not going to tell you not to use a standard. We're not going to tell you to use a standard. We want to make the playing field level and let the customers decide what they want to do and what works best for their own workflows. And so that's been our angle. And then we really try to make these calls. We've bet on some standards before that haven't gone anywhere. There's some standards that the only way to get in and out of them is through FME, which makes you wonder, why did we do this? But hey, it was needed for some region in the world, and that's the way. And I guess at the end of the day, it's good for business. But anyway, our goal is to remove the friction so that customers can choose whatever works best for them, and then just let the market decide afterwards.
So you have a really interesting role in the world, I think, and because of that, you get to meet in a very non-threatening way, I think, with lots of different companies and groups that might normally be competitors, but they're not a competitor to you. You're a bridge builder, I think,
Yeah.
among so many different people and so many different companies. So I imagine that you're able to look into the roadmaps of some of these just a little bit, because you need to be prepared when they introduce a new piece of functionality or a new data model. What trends are you seeing in the world that are most exciting to you, that you think are going to deliver the most impact in the next 5 years?
On one swath of things, we just see the data volumes exploding. So we've been doubling down for several years on trying to make our FME product as powerful and fast in the face of huge data volumes as we can possibly be. We've always been flexible, and our traditional approach does make us pay a price in the face of high data volume, but our team managed to figure out a way to have the best of both worlds. So that has been a big thing. So that that's really about getting stuff into the data lakes, and the whole use case of, we often called ourselves spatial ETL, extract, transform, and load. And then there's another way of thinking about that in modern times where you say, I would say spatial ELT. So extract, load. So, hey, we're going to get the data from wherever it is. We're going to load it into a data lake. And then basically where our job is done as safe software. So we got to be high speed for that. And then the T will be done using the tools of Snowflake or Google BigQuery or whatever your Redshift or whatever your huge data lake is. So that's one side of things. Another interesting area is the whole graph databases and kind of reasoning around knowledge. Esri's got a big initiative there. There's some of our customers have dabbled with those things for infrastructure, like the IFC extensions for infrastructure and roads, putting that into a graph database and doing things. There was some prototypes there that I think are pretty interesting. On another side, we see we are part of this Gartner Magic Quadrant stuff, and we're in there rubbing shoulders with not spatial folks, but folks that care about different kinds of data practices. And from there, we're learning about the importance of data lineage, knowing where data came from, how you got it, all kinds of the value of metadata. And we're looking at ways we can add more value to that, to the spatial world, where these things haven't been at the forefront as much as they probably should be. And related to that is also the idea of data ops. There's DevOps, but there's data ops, and how can we make sure that we are good citizens in that kind of world? And across all that, this explosion of endpoints where you can get data to augment your workflows or that are really driving your workflows. Again, streaming of data, real-time processing, another area that we've done some work on lately and we have customers doing more and more with, but that's a big emerging thing. Data being collected through IoT devices, needing to have something done to it. It's just too much, even in its raw form, to just huck it into the data lake. You want to do a little bit of T transformation along the way. But the one that I'll sort of finish up on is that's most exciting to me, is the whole impact of augmented reality. Virtual reality is one thing, but I think for the world that our customers live in, and I would argue, Stu, the customers of yours as well, the augmented reality side for understanding what's behind the wall, what's under the floor, what's under the road surface, and seeing it and reasoning about it, I think that's an extremely fascinating area. And normally at SAFE, we don't write end applications ourselves. We look for somebody else that's written the application, and we find out about their format or their API, and then we connect that into the FME workflow system, and off we go, and we can support it. But we took a look around, and we didn't really see anything that was a compelling visualizer for geospatial data and augmented reality. So we've written our own for now, and it's kind of a place where we can experiment. And if others come out with things, we'll be happy to support their formats as well. But it is very, very stunning what can be done with augmented reality with the right mix-in of carefully prepared, high-quality input data. And I think when we see consumer affordable but professional grade hardware that's in these glasses that I'm clumsily wearing right now. I think that has the potential to really provide huge value and a super exciting and compelling endpoint for actually our common customers and many, many others that don't even know that they need this yet. So that's the part that I'm the most excited about of all.
That's fascinating. That will be a really fascinating trend to watch, actually. You're starting to see kind of early glimmers of that, but the potential there, I think, is really, really exciting.
Yeah, we've been, again, it was sort of I would call it a hobby project of ours, the AR side of things. Nobody buys our product for that today, but I've seen from out in the field some of the early things that customers have been doing, and it is pretty mind-blowing and adding a huge amount of value to the person out in the field inspecting water systems, or you're trying to reason about infrastructure that's buried. Or you're even just trying to understand better the road marks that are out there. You can augment them as well with labeling and so on. It's so fascinating, and I do think there'll be a tsunami of products and options once it becomes a bit more mainstream.
Dale, I've asked you a number of wide-ranging questions today. What questions have I not asked that I should have? What parts of your experience and perspective would you like to share with our viewers that I haven't really asked you about yet?
Well, on the softer side of things, we can talk all we want about technology and different approaches, but in the end, it's really the relationships between software providers, data providers, and the customers that really are the things that are honestly the most important and the most rewarding in the longest term. And so, the thing that I feel so blessed about is that the position we ended up in the industry allowed us to be, like we used to say, the Switzerland of GIS, this neutral party that allowed us to work with all kinds of experts. And we do it today still, people that are just top of their field, and being able to learn from them and add value and take what they're doing and grow it and expand it, connect it. It's really been such a wonderful, wonderful thing. And, recently we had someone from our industry pass, Martin Eisenberg from Rapid Lasso, a true LiDAR expert. And it's those moments that make you reflect on really the importance of each moment and of all these relationships. And so that's the note that I would want to encourage all of the viewers today to make sure not to take those for granted in your daily lives, in your professional lives, and maximize them, because I think, as Elon Musk just tweeted, time is the only valuable commodity, and we only have so much of it, so let's make the most of it.
Thank you, Dale. It's always a pleasure to visit with you, and I'm so grateful for your willingness to be part of this series. Always a joy and a pleasure to chat with you, and I hope that some of our viewers will get a chance to know you as well.
Well, we'll have to try to catch up at a playoff hockey game like we did one time years ago again.
That would be good. Yes, I'd like that. Thanks, Dale.
Okay, thank you so much.